Your hands together to be welcoming on stage Mr. Ajinkya Kulkarni, Process Engineering Expert, Raj Industry Limited. You'll be using the podium mic or you want a hand mic? Hand mic.
Hello. So, good evening, everyone. So, I'm Ajinkya Kulkarni from Praj Industries. So, I'm giving presentation on the basically beer recovery from surplus yeast and CIP solution and whatever the new offering we are offering to the customer in the craft brewery section and industrial brewery section. So, these are my three topics: beer recovery from surplus yeast, CIP system in beer industry, and new offering to the beer industry. So this is a basically Booker cross flow filtration which handle the surplus yeast and that surplus yeast, from that surplus yeast we can recover the beer and use as a direct sale. So many breweries nowadays approximately draining 2% beer in the yeast. Whatever the yeast is recovered from the fermentation, that yeast is having a 2% beer. So that is presently drained to the ATP. And disposal of this yeast is very critical from BOD and COD point of view. So to recover that yeast, we have different membrane technology, and we have tie-up with Booker Filtrox, Booker Unipectin Filtrox. So this cross-flow filtration will help to recover the beer from this wastage basically. And every brewery nowadays is using making a dry yeast, which is used as a poultry, which is sent to the poultry, and which is having high protein basically. So this will reduce the ETP load. But while doing that process, whatever the liquid is generated, that liquid is sent to the ETP. So ETP will having a BOD and COD that will increase. So to avoid that, we can use this big beer recovery system. And from beer recovery system, whatever the beer is generated, we can use and dilute the beer, main beer. And the yeast will be sent to the dryer basically to dry the yeast. So there are presently three technologies: chamber press, whatever the hydraulic press is available, that with the help of hydraulic press, we can compress the yeast and we can separate the liquid and solid separation. And second will be separator. Separator is a centrifuge. From centrifuge, we can pass the yeast in centrifuge and we can concentrate that yeast, and whatever the liquid is there, that liquid will send to the gutter, and whatever the concentrated yeast is there, that will use as a further process for drying process. And third one is the CMF BR. CMF is a cross-flow membrane filtration. So with the help of that, we can recycle this beer and use as it is without compromising the quality of the beer. So these are the basic parameters which we have done the analysis with the chamber press, centrifugal separator, and cross-flow filtration. When we use the cross-flow filtration, our OG reduction, whatever the sales OG of the beer, that will not reduce because it is not diluting the beer. So in all the cases, it is not dilute the beer basically. Turbidity in the cross-flow filtration is a comparatively chamber press and centrifugal separator, it is a less if we see the parameter. And DO2 pickup, it is a definitely closed system, so oxygen pickup is also less in that case. And whatever the filtrate yeast is there, when we separate the yeast, so there are chances of the yeast will come with the beer. So that will also chances is less. It's up to 1 per ml only. And third is the autolysis protect. Whatever the breakdown due to yeast breakdown, whatever the yeast is breaking, that is absent in the cross-flow filtration. When we will transfer the beer into, we are making beer from cross-flow filtration. And definitely protease activity is also not increased when we use the cross-flow filtration. So basically, these are the merits and of cross-flow filtration over the other filtrations. Definitely, it is depend on the yeast quality and its quantity, whatever the yeast type is using. So it may vary case to case basis. So basically, this is a cross-flow filtration. Whatever the traditional filtration is there, that is a flow, is a parallel to the what we can say young beer or input to the output flow. But in cross-flow, it is a crossly perpendicular to the main feed flow. So that is the main difference in this. And in the traditional way, we can decrease the flow rate when time is increased. But in dynamic cross flow, when time, with respect to time, the flow rate is constantly we are getting. Definitely, whenever there is a pressure drop, flow will decrease. But with respect to traditional, it is a less decrease of flow. So we will get a more throughput compared to traditional system. So basically, this is the yeast is sent to the yeast tank. There is a circulation method. So by doing a circulation, we will get the concentrated yeast, uniform yeast, and then it will transfer to the basically membrane-based filter. And in membrane-based filter, depend on the pressure transmitter and flow meter. Whatever the beer is there, that filtrate is coming out, and it is again recirculated. And whenever there is a pressure difference is less, with the help of deaerated water, major quantity of deaerated water, with the help of control wall, we can add the deaerated water. So whatever the flow rate is there, that flow rate will increase, and that will improve the basically beer recovery from the yeast. And at the end, whatever the yeast is there, that concentrated yeast, that is we can send to the dryer basically. So this is a simple flow diagram. We have installed this beer yeast recovery from cross-flow filtration in one brewery in India. So CMF can recover beer loss from yeast as it is a high quality of beer. So we can use as it is and sell as it is. This recovery also reduces the effluent burden. Basically, I have discussed earlier. So whatever it's a beer and yeast is having a higher BOD and COD value. So if we recover this yeast and beer, then that will decrease the BOD and COD value of the ETP, and simultaneously it will reduce the BOD ETP load basically. So recovery of beer needs less energy. Whatever the traditional way we are making a beer, so whatever the consumption is required per HL or per kWh, in beer recovery system it is comparatively less if we do this beer recovery. And it will give maximum 90% yield. Again, it will depend on the generation of the yeast, which type of generation yield we are using for this cross filtration. It's a fifth generation, sixth generation. So depend on that regeneration, that depend on the yeast quality, type of the yeast. This efficiency may vary. So definitely it is a complete automatic process. So operator interference is very less. And depending on the size and whatever the production capacity, so payback time is vary from 1 year to 3 years. Whatever the beer, presently it is sent to the ETP only. So it is a wastage to the brewery. So what if we install this, then that wastage we can convert into money. So that's why payback period it is in the less than it is in between 1 to 3 years. And considering the various beer production unit, whatever the volumes are there, it may calculate detail, and we can provide the detailed calculations. My second topic is a Praj offering hygienic CIP system. So basically the importance, as everyone knows, importance of CIP, because we are doing with the food and beverages industry. So CIP is very important to do this to control the growth of microorganism, and it will improve the hygienic condition of the complete plant. So without dismantling of the equipment, piping, we can do the CIP. So these are the basically importance of the CIP which we are doing to the industry. Traditionally, people are doing two types of CIP system. One is a single pass system, that is a dumb CIP. So simple tank is there, pump is there. With the help of the that caustic preparation, we can do the CIP, and after the CIP, we can drain the caustic. And second is a 3-stage or 5-stage CIP with recirculation system. So all the old breweries having this either dumb CIP system or 3-stage or 5-stage system. But nowadays, whatever the Heineken, Carlsberg, UB, AB InBev has entered into the market, so the quality of the beer, quality of the CIP has improved. So now whatever the demerits are there mentioned in the CIP system, because we are using the same CIP for filter area, beer filter area, and beer non-filter area, unfiltered area basically. So same caustic we are using, same tank we are using. So there are contamination issues, CIP solution contamination issues are there. Then if some people are draining the caustic and again prepare the caustic. So if there is a shift change and first operator has done the CIP of unfiltered area, and now second shift operator want to do the CIP of the filter area, and operator has not communicated that, then unfiltered area CIP solution can be used for filter area. So chances of mistakes are there. occupancy of vessel is more due to unavailability of CIP system, because these are 3-stage and 5 stages of one CIP system. So I want to do the CIP of Unitank, and simultaneously I want to do the CIP of BBT. So this will increase my occupancy of the Unitank and BBT. Then frequent draining of caustic acid water, so more consumption is required. Impact on product quality, definitely. More skilled manpower is required, as mentioned earlier. And due to frequent caustic and acid draining, it will increase the ETP load. Nowadays, ETP is a very challenging in the every brewery. So to reduce the ETP load, we can we are offering the system. So whatever Praj offers CIP system is a dedicatedly separate CIP for each section. Brewhouse CIP, which is cater for brewhouse kettle, reboiler and pipeline. Vote cooler CIP, that is a dedicated vote cooler CIP with automation. Cellar cold CIP for unfiltered area, that will be used for unitank, pre-filter buffer tank and yeast tank. Cellar cold CIP for filter area for BBT, post buffer tank and DAW tank. Cellar hot CIP for unfiltered area, that is unfiltered area pipeline. And CIP, cellar CIP, hot CIP for filter area. So that will be used for filter area pipeline. So the above system is designed accordingly to the requirement of the respective area. So product pipeline size, whatever the CIP is there, generally it is with respect to velocity. So we can design optimum design we can do for filter area CIP and unfiltered area CIP. So CIP flow rate, definitely my filtration is for example 200 HL per hour. So my CIP flow rate should be 300 HL per hour. But whereas young beer, my bright beer, when I'm doing dilution, then that flow rate will go to the 300 HL per hour. In that case, my CIP flow rate is also increased. So as per the CIP flow rate, we can design this above system, and we will maintain this velocity basically. This velocity will create a turbulence during the CIP, which will give better efficiency of the cleaning. So these, if we do the dedicated CIP system in each area, that will improve the quality, quantity of quality of the beer basically, quality of the CIP solution, which we can reuse every time, and we can top up as per the concentration requirement. So what are the advantage of the CIP system? No CIP solution contamination, as a separate tank and loop is used to avoid contamination. Chances of mistakes are nil due to a separate loop. Occupancy of the vessel is less, as there are separate CIP loops. So today I can do BBT CIP and Unitank CIP simultaneously. Less consumption of caustic acid water, as we are using a same solution, as there is a filter area and unfiltered area CIP is there. So we can use the same solution with increasing the concentration of the CIP solution. Improve product quality, as a filter area and unfiltered CIP loops are different. Less skill manpower is required, as the chances of mistakes are less. And added safety of employee due to very less exposure of chemical, because we have to not prepare the chemical solution frequently. These are the CIP solution. And my third topic is a Praj and Booker Denwall new offering. As you know, Praj and Booker is having a partnership for India, and Booker has a partnership. Booker has a Booker Denwall is a joint venture, and with the help of this Booker Denwall, we can offer the system to the customers basically. So they have dedicated skid system of inline aeration and oxidation skid, manual and auto carbonation skid, cross flow filtration, water deaeration, auto dosing system, flash pasteurizer and carbo blender. So we can offer this to the craft industry as well as industrial brewery. So these are the end of my presentation. So if you have any queries, you can connect to us at any time. We can resolve your we can give the solution to your problems, or whatever the you have any issue on the existing system. So that's it. Thank you.